So if I told you to find the fourth derivative of the basic polynomial x to the power of 4, how would you do that? Well, first you would use the power rule to find the first derivative. So f prime of x is equal to, you bring the 4 in front of the x, you get 4x, and then 4 minus 1 is equal to 3. So your first derivative is 4x cubed. And then for your second derivative, you work off your first derivative. F double prime of x is equal to, you bring the 3 in front of the x, so you get 3 times 4 is equal to 12, 12x, and then 3 minus 1 is equal to 2. So your second derivative is 12x squared. And then for your third derivative, f triple prime of x is equal to, you bring the 2 out in front of the 12, so you get 2 times 12 is 24, x, and then 2 minus 1, so you just leave it at x. And then for your fourth derivative, f to the fourth of x, you bring the 1 in front, so you go 24 times 1 is 24, and then 1 minus 1 is 0, so the x will vanish, so you'll just be left with 24. And then for this here, your first derivative, or our 4x cubed, will give us the rate of change of a function. The second derivative gives us the rate of change of the first derivative. And so oftentimes when we're given a problem, a word problem, and we're asked, and we have to use this as the process, that can represent the concavity, or it can represent the acceleration of something. Let's try another problem. Let's say I were to give you this time, instead of a basic polynomial, I gave you a trigonometric function. Say I gave you f of x is equal to sine x. And I told you once again to find the fourth derivative. Well, f prime of x, and this is something you just have to memorize, is going to be equal to cosine x, which is the derivative of sine. And then for f double prime of x, we're going to be finding the derivative of cosine, which is negative sine x. For f triple prime of x, we need to find the derivative of negative sine x, which, as you might have guessed, is negative cos x. And then for f to the fourth prime of x, we find the derivative of negative cos x, which is simply sine x. So as you might have noticed, sine and cosine cycle every 4 derivatives. Now let's try just one last problem, but this time we're going to use an exponential function. Actually, let's try 2 more problems. First, let's use an exponential function. Say I were to give you f of x is equal to e to the x. What's the first derivative of this? Well, f prime of x is going to be equal to e to the x, since the derivative of e to the x is e to the x. And f double prime of x is also going to be equal to e to the x. And as you might guess, we can just keep going down and down and down, and it's always going to be equal to e to the x, because the derivative of e to the x is simply e to the x. And we're going to stop there for today. So to wrap up, higher order derivatives are just repeated differentiation, so they can give you information about concavity, acceleration, and patterns like cycles and trig functions or constants and polynomials. Now be sure to practice these, as they do take practice to get used to. I hope this video helped. Thank you.